So welcome everyone, and thank you very much for joining us this evening. This is the 5th event in the Transition Clean Air Network webinar series. Transition is a UK-wide clean air network which focuses on delivering the health and air quality benefits associated with transport decarbonisation. Our network is in collaboration with 9 universities and 20 cross-sector partners. We're also supported this evening by the University of Birmingham Institute for Global Innovation, which seeks to inspire, support and deliver world-leading research that addresses the world's most pressing challenges. So this evening, our event will focus on Euro 7 emissions regulations, considering whether these will deliver improved air quality and better health. I'm now going to hand over to our event chair, Professor Sam Akehurst. Sam is a Professor of Advanced Powertrain Systems at the University of Bath and Research Director at IAPS, the Institute for Advanced Automotive and Propulsion Systems. He leads a wide range of collaborative low-carbon and zero-emissions powertrain research projects with a range of automotive industry partners. He's interested in air quality challenges in the automotive sector from a technology standpoint, with respect to the adoption of more stringent emission standards and measurement of non-exhaust emissions. Welcome to Sam Akehurst. Thank you.
Thank you, Suzanne, and welcome to everyone else here today. So I've just got a few housekeeping things to ensure first. So attendees at this, if you have questions, then can you please use the Q&A tab at the bottom of the Zoom screen to put your questions in there? And can you please make sure that all microphones are muted throughout the presentations and discussion? I think this is a great topic. We've been waiting for Euro 7 legislation to be announced for a long time, and now that we know what that legislation is, then hopefully this seminar will allow us to understand the implications on health and well-being to a greater degree. For now, I'm going to start by introducing the people we have on the panel today, and I'd like to kick that off by introducing Felix, please.
Yeah, so good evening, everyone. My name is Felix Leach. I'm an Associate Professor of Engineering Science at the University of Oxford. My expertise is in emissions measurement and efficiency in thermal propulsion systems generally and their impact with air quality. And I've run a number of projects both on vehicles and also air pollution, both in Oxford and more widely. And it's great to be here to discuss this really important topic. Thanks, Sam.
Thank you. And our second panel member is Stefania.
Good evening from my side. So my name is Stefania Esposito, and I'm lecturer of Sustainable Propulsion System at the University of Bath and IAPS as Sam. So my research interests are related to efficient and clean combustion of sustainable low carbon fuels, and I'm both involved in the experiments as well as simulation. And I'm interested in the reduction of pollutant as well as CO2 emission from future transportation and all the challenges connected with the adoption of policies to quantify the pollutants from transportation. Thank you for inviting me here today.
Thank you, Stefania. And our third panelist is Ameya.
Hi, everyone. Thanks, Sam. Thanks for joining. My name is Ameya Joshi. I work for Corning Incorporated. My role is that of Director of Emerging Technologies, Regulations, and Electrification. So what I do is I track regulations and new technologies that are in the next, I would say, 2 to 10 year time frame, which lead to better tailpipe emissions from cars and trucks and to transport decarbonization broadly. So thanks for inviting me.
Thank you. And our final panelist is Nick.
Thanks, Sam, and welcome everyone. I'm Nick Molden, founder and chief executive of Emissions Analytics. We're an independent test house operating around the world. Our particular mission is to understand what really happens in terms of vehicle emissions, seeing what happens on the road. And this is particularly relevant in all the live current discussions of Euro 7, decarbonisation. We've had too often official regulations which have promised a lot and delivered not so much. So actually delivering and achieving environmental improvements is what motivates us. Thank you.
Thank you, Nick. So to kick off with, we're going to have a short presentation on the Euro 7 regulations and the implementation of them, given by Amelia Joshi. And we will discuss, after that 10-minute period of that presentation, we'll have some discussion between the panel about the implementation of Euro 7, and we open up to the audience to put questions in the Q&A session for us to discuss and answer. So over to you, Amelia, for your presentation. Thank you.
Thanks, Sam. And just for everyone who's attending, so these slides I think will be made available, but there's still a fair bit of information here. I'll try to be quick because we want to keep time for Q&A, but that's my contact information here as well. You can connect with me on LinkedIn. So I'll just go over what we know about the regulations today and what the technology implications are, right? So let's start with the first slide. So I just want to start with a little bit of maybe good news is that, we have indeed been cleaning up our environment, right, in the past several years through various regulations, not just for tailpipe. But so you can see here, taking European cities as an example, most cities have gotten cleaner with time, and in fact, most are incredibly clean, well below the sort of good air quality recommendations. And so, yes, that's good. And by the way, I'm showing here the PM 2.5 or concentration of particles which are below 2.5 microns, right? These are associated with lots of health issues. So yes, these cities are clean, but the World Health Organization has come up with new air quality guidelines of 5 microgram per meter cube as the recommended limit for good health. And so there's more work ahead in terms of cleaning up the air, right? That's the motivation for the next round of regulations primarily. Yeah. So next slide. So again, just taking a step back and looking at the past regulations, I think it's worth just taking a look there. It's incredible how clean cars are today. If you go all the way back to Euro 1, which started in the 90s, so in the past 3 decades, we have already made over 80% reduction to hydrocarbon and NOx emissions. And in Euro 6, as you all know, the RDE or real world driving emission limits were introduced, which made sure that cars are as clean on the road as they are under lab conditions mostly. But then there's still some driving conditions in which cars and trucks could be emitting more. And so Euro 7 aims to eliminate some of those high emissions, right? I also include LEV 3 here, the US regulations, to show that those are still much cleaner for the diesels today, right? Now on the right is particle mass limits, and again there you can see tremendous reductions over time. You can barely see those limits on the plot there towards the end, but the key was introducing particle number limits for Euro 5, 6, and then now that so-called conformity factor will be eliminated, and also particles below 23 nanometers all the way to 10 nanometers will be included in Euro 7, which makes this a more stringent regulation. One quick note, so there's emissions from tailpipes, but also now with tailpipes getting so clean, there's a growing realization that non-tailpipe emissions are actually becoming even more of a concern. And these, are particulates generated from tire and brake wear, right? And so, and especially for electric vehicles, which are heavier, tire wear is seen to be a bigger concern. So there is a placeholder for these emissions as well in Euro 7, right? Okay, so next. So this is just looking at the fleet today, and I just want to make the point that while we are talking about Euro 7 as applied to new vehicles, there's clearly an understanding that the existing fleet is massive, right? And we need to make sure that we're cleaning up that as well. So for example, Europe today we sell about 15 million or so vehicles, right? And 1 in 10 cars is an electric. But if you look at the overall fleet, there are 250 million vehicles on the road today, and EVs are only 0.5%. So most of the vehicles today are still diesels and petrol, right? And of those, more than half, more, in fact 60% of the cars are pre-Euro 6. So there's a lot of opportunity to clean up the existing fleet using low carbon fuels as an example, right? And making sure that the emissions control that we have in place are working correctly. So the high emitters, often the 10% high emitters are associated with like 90% of the emissions today. So making sure that, you know, cleaner fuels and ensuring systems working on the road in real world conditions is very important to keep cleaning up the fleet today. Yeah. Okay, so so just a very high level overview of the various elements in Euro 7. And by the way, Euro 7 means both for light and heavy duty. So this holds for both. So one is the fuel technology neutral limit. So the same limits would be used for gasoline, diesel, natural gas, and so on, and same for cars and vans. As I said earlier, particles down to 10 nanometers will be included, not just 23 nanometers, right? Emissions are measured on random and worst case RD test cycles. So previously there used to be a prescribed RD test cycle with urban, rural, motorway driving. Now that's gone. You can measure emissions on all conditions. Durability requirements are increased. New species are being regulated. I give a couple of examples here. Ammonia for light duty has a limit now, and an N2O for heavy duty. This concept of onboard monitoring, so not just onboard diagnostics, but continuous monitoring and then relaying that data back to regulatory authorities, so through telematics, and also monitoring of fuel and energy consumption, right? That's included. And then the rest, I won't go through all of this, but there are other provisions to make sure that the cars are clean and you know, including non-tailpipe emissions and so on, as I mentioned earlier, right? Okay, next. So these are the actual limits, right? I mean, if you look at the table on the right, you can see that the first two columns are Euro 6, then the next are Euro 7. There is let's start from the very right. There's a new concept of a budget introduced, and that's for short trips. And the idea is, look at the units, there's total milligram or total number of particles. So the idea is that if you're going to measure emissions on a short trip, the emissions should be below this total amount, right? So for example, NOx should be below 600 milligrams. And then of course, there's the traditional way of milligram per kilometer, so which is 60 for Euro 7. It remains the same as the gasoline limit in Euro 6. So for diesel, it's a bit of a tightening. And then particle number limits, again, remain the same as Euro 6, but there are particles down to 10 nanometers included, right? And there's no conformity factor. That's a big change. So there's no, like, WLTP and RD would be the same limits. And we can go down the list, but essentially that's sort of the main changes. And ammonia, as I said, you know, there's implications for diesels, right? That ammonia, you have to meet a limit there as well. On the left is perhaps even more important, because what this says is that now the boundary conditions have expanded. You can test cars down to -10 C to altitudes of up to 1800 meters. Trip composition can be any. So again, you can just test a vehicle under all driving conditions. And you know, so some other conditions listed there, but essentially just that the boundary condition makes this a much tougher regulation, I would say, more than the limits itself, right? Okay, so next, yeah, so just wanted to show a couple of studies to say why this is a stringent regulation or not. I mean, we can discuss this, but the left is from a study done in Korea. And Korea has interesting, they follow European regulations for diesel and US for gasoline. So I'm just showing the diesel portion. What they're showing here, and you can just see, is that the average NOx emissions have reduced with time. Note that the y-axis has a different scale there. But anyway, it's reduced with time, and then you can see that, especially going from Euro 6B to Euro 6D with the introduction of RD, the emissions have dropped significantly, right? And they are actually well below the Euro 6 limits. Now I've shown the Euro 7 limit there, so there's some instances in which these cars would have exceeded Euro 7. So that's the cleanup that's happening, right? Or will be required. On the right is particle emissions from gasoline vehicles. And this was a study done at the Joint Research Center at the European Commission. This was a Euro 6 compliant car with the GPF. And what I want to show is, look, this car does meet the regulations very well for WLTC at room temperature. But as you start making the conditions more stringent, you see that the same car now begins to exceed the Euro 7 limits. So basically, things like adding the sub 23 nanometer particles, doing a hard acceleration, adding driving car under urban driving conditions, and adding a cold start, and then finally doing all of this testing at -9C. So you slowly start emitting more and more and more particles, and that's again the kind of conditions that Euro 7 is targeting, trying to make sure cars are clean under all driving conditions, right? Okay, so next, so potential solutions. Again, I'll be quick, but just want to show a few representative systems. These are emission control systems at the tailpipe. So starting with the three-way catalyst only system, GPF, so gasoline particulate filters, have been introduced for Euro 6 already, but going further to Euro 7, you would expect additional three-way catalyst content, things like hydrocarbon traps, passive SCRs to address the ammonia limit, and then also electrically heated catalyst. By the way, the GPF can be in the underfloor, the second position as well. I'm just showing this as an example, and it could be bare or catalyzed to further give three-way catalyst functionality. On the diesel side, there is, of course, the DOC DPF SCR has been the traditional sort of Euro 6 or LNT, lean off strap, but now it would be addition of a second SCR, so the short SCR brick close to the engine for early light off, and then with dual urea dosing, right? So that's the key. It will be another urea dosing, more ammonia, and so you need also better ammonia slip control, but also could be an electrically heated catalyst. That's important for NOx control to get the catalyst hot sooner, right? So these are some of the main changes for the light duty side. Yeah. So next, moving to heavy duty, similar sort of format as light duty. You can see the boundary conditions on the left, which are conditions for acceptable test, and then the limits on the right. So on the heavy duty side, the limits are actually tighter than Euro 6, and you can see NOx going down all the way to 90 milligram per kilowatt hours. Note the units in heavy duty are different, right? It's the work base, so it's per kilowatt hour. But down from 460 to 90. There's also this idea of budgets, and this time it's 3 times the work done on a WHTC cycle, and that's the so you can do a test that covers anything up to that much of work done, and you have to meet the limits on that column. There's a particle number limit also for heavy duty, and that tightens from 6e to the 11 to 2e to the 11 for this 90th percentile. And then you can go down the list. I think methane limit is important for natural gas. You have the N2O limit, which is important for diesels. So again, quite a few interacting parts here, which make this a very strong regulation, right? And then again, by the conformity factor, so those limits have to be met under all real-world driving conditions. And left table shows the boundary conditions, also very broad, going all the way to -10C and under all sort of normal trips for the intended application of that vehicle, right? So and the lifetime has also been increased significantly for these heavy duty trucks. Yeah. So the next, and I think that's my last slide, I just want to show you examples also for the heavy duty side. So first, just the table on the left to make an acknowledgement that not everything is just emissions control at the tailpipe, but also there's improvements that will be happening and are happening on the engines, right? So different engine calibrations, cylinder deactivation is a new technology, and we can go down the list. But there's clearly improvements on the engine and also on the fuel side that can be made. But clearly a lot of emphasis will be placed on advanced operating systems. And the key concepts right now are adding a second SCR close to the engine. So this closed coupled SCR, which again just heats up quickly because the exhaust, it's exposed to the exhaust, and followed by a DOC, DPF, and then SCR. The DPF has this asterisk because we do expect the DPF to be very high filtration to meet the added PN or more stringent PN requirements. And then, also electrically heated catalysts are being discussed, and other sort of active thermal management systems are being discussed. And finally, also a second DPF, that last system you can see is an interesting concept, because urea particles are being detected as solid PN, and there's the possibility of those helping to exceed or making the vehicle exceed the limit. So possibly having a second filter is also being discussed. So quite a few new systems and components being introduced, and you can see these are getting fairly complex, but also robust in terms of meeting the Euro 7 regulations. So yeah, that's all I have for now, and then let's see how we get some more questions on this.
Thank you for Amia. That's been a very useful presentation to kickstart the discussions. So I wanted to kind of get some conversation going between the panel members. So first off, I had I think a question that Nick would be good at answering, which was these Euro 7 regulations. Do we really need them? Aren't we all going to be driving battery electric vehicles by 2030? And haven't internal combustion engines been banned?
I think the short answer is yes, we do. And the reason perhaps that we don't is what Amaya showed on his slides, the current breed of Euro 6 vehicles, whether petrol or diesel, are by historical standards incredibly clean. So you could say, why bother? But I think there are three reasons why we do need it. Firstly, Euro 6, frankly, is a confusing mess of a regulation. And in fact, the slide showed it, that the early Euro 6s, the pre-RDE, as they're called, average something around 400 milligrams per kilometer of NOx, yet the ones after RDE average about 40. So a 90% reduction, yet to the eyes of a consumer trying to buy a car and do the right thing, it's Euro 6, they're both Euro 6. So that means that Euro 6 as a label is a complete failure, and Euro 7 solves that by drawing a clean, fresh line, and also is technology neutral, which is also a good thing too. The second reason, I think, and maybe a little controversial, is I don't believe that the ICE ban in 2035 will be deliverable. So I think internal combustion engines, probably all hybridized to one extent or another, will be on sale long after 2035. And we need to make sure those are as clean as possible. And the third is Euro 7 includes non-exhaust emissions, brakes and tyre wear. So even if we all go electric, we hugely underestimate the environmental damage from particularly tyre wear emissions, and Euro 7 for the first time is trying to put a limit on that. So that is really, really important, even if we all go electric. So yes is the answer. The one caveat I would put on it is that it must focus on what it's intended to do, which is drive reduction in tailpipe and non-exhaust pollutants. It mustn't be used as a pawn in the wider decarbonisation debate. In other words, just be a means of making internal combustion engines more expensive to try and drive them out of the market. And I would say that certain quarters see Euro 7 as an opportunity to do just that. So I think it needs to be carefully calibrated to the environmental benefit that it derives. But overall, I would say, yes, we do.
Thank you. And then I'll move on to Felix. I wanted to talk you to kind of comment on zero emissions and Euro 7. I know you've done lots of research on other factors that influence background emissions, and kind of comment on the magnitude of how these Euro 7 regulations might influence those.
Yeah, thanks, Alice. It's a great question. I think so. Start with the zero emissions tag. I think we need to be really clear about what Euro 7 is and what it isn't. So this legislation is focusing almost entirely on what we call pollutant emissions. And Amaya gave a really nice overview of those. So we're talking about things like particulate matter or soot, NOx, hydrocarbons, ammonia, all these types of emissions. But what we're not talking about is carbon dioxide. And so the emissions that we are talking about are the ones that affect our health as we breathe them in, and particulates in particular are a real issue still today. We've made better advances with NOx, I would argue, but we're not talking about CO2, which is something that leads to climate change and is a greenhouse gas. And that's being handled in Europe, at least separately, mostly through the Fit for 55 package. And that's where the kind of talk of an internal combustion engine ban in 2035 comes from. So I think it's really important that we just distinguish what this is and what this isn't trying to do. And then to sort of come on to the second part of your question, Sam, I think what we're seeing here is something that is going to have a significant impact in emissions reduction, but this is only going to focus on transport. So the nice thing about this legislation is, as Amer and Nick have both said, is it's technology neutral. So it's going to apply to petrol vehicles, to diesel vehicles, to hybrids, to plug-in hybrids, to battery electric vehicles, to hydrogen vehicles, you name it, it'll apply to them. And in particular, the introduction of non-tailpipe emissions, such as tires and brakes, is really important there. But it's still only focusing on vehicles, so trucks, lorries, cars, etc. And it's not focusing on all the other sources of emissions. And for example, in Oxford, what we see is actually the majority of particulate matter does not come from transport. It comes from other sources, particularly domestic combustion, and so on. And solid fuel combustion in particular is a really big source. So I think we need to celebrate the advances in the Euro 7 legislation, but acknowledge that this is not going to fix the problem. And as with all sort of things to do with air pollution, I would say it's a bit like a really complex soup. And we're going to need this legislation, but also lots of other factors to drive improvements in health through air pollution reduction in the UK and worldwide.
Okay, thank you, Felix. And Stefania, just to bring you into this, your research background, you're interested in low carbon and sustainable fuels, and part of that is talking about synthetic fuels. Do you see that they have a future through this emissions legislation, and is there anything directly associated with Euro 7 that is going to influence the uptake of synthetic fuels?
Yeah, thank you for this question. I think it's a very good after what Felix said. So actually the fuels topic, so synthetic fuels or also e-fuels, are so carbon neutral fuels that can help us from the CO2 side of the problem, so global warming. And so they are considered like a way to store and transport renewable energy produced from a different part of the world, or a different time where renewable energy cannot be directly used. And actually, they are seen mainly as a necessity for decarbonized fast transportation in the coming years, in a faster way than relying on only electric vehicle penetration. Of course, they are still fuels that will be, let's say, they can be associated to pollutant emissions. So of course, they will, if they will be applied, they would need to fulfill the emission regulations. But so they have some benefits because they could be formulated in a way to be drop-in, so to have comparable properties to actual fossil fuels. And for that, we could use it in current internal combustion engines, or we have already transport and distribution infrastructure for them. So they could be seen as a good option for countries that cannot keep up with the electric vehicle infrastructure, or cannot fulfill the scale up of the renewable energy production. The point of discussion here that is, let's say, not so much bound to the Euro 7, but mainly more to the Fit for 55 that Felix mentioned, is that the usage of synthetic fuel, as well as the usage of renewable fuels or whatever other source, it's not allowed after 2035, at least at the current state of the proposal, because the requirement would be there to have a zero CO2 from the tailpipe. So even if they are carbon neutral, and theoretically the carbon neutrality is our target on the specific let's say, system of vehicles, we focus only on the tailpipe. And so this is the reason why many countries see so a debate point, and probably everyone has heard something about that, especially in the last weeks. So to conclude, the e-fuels or synthetic fuels would need to be clean and let's say stay under the Euro 7 regulations, but it's right now the current proposal will not allow them to be used after 2035.
Okay, I think that's been a useful discussion. And Emilia, just to you, and I think others have touched on this, the importance of Euro 7 is it actually achieves what it's set out to do, which is to minimise air pollutants, specifically from transport. Do you see any unintended consequences of the Euro 7 legislation as it's proposed at the moment?
Well, I think Nick kind of mentioned that a little bit. I think the worry is that it shouldn't be used as I like how you phrased it, a pawn in the overall scheme of trying to get ICs banned. That shouldn't be one of the that could be one of the unintended consequences. It's being used as a that's going to add so much of cost that lets just move all towards electrification. Or so I think that's one. Honestly, I worry a little more about, it's not directly pertinent to Europe, but it's how China and India, for example, are going to follow. It's very important for the rest of the countries who follow Europe to see how Euro 7 is evolving. And this whole confusion on, well, we're just going to keep it not too tight, or we're going to make it super tight, it's sending wrong signals to other countries, and which, by the way, do need a lot more reduction, that they don't have as clean air as in Europe. And so I think that's the other aspect that I think I'm closely watching. Euro 7 should be set in a way that gives a good signal to the other markets.
Thank you, Emilia. I think that actually leads very nicely into one of the questions we've had online, which is, can Euro 7 be implemented around the globe? And although we appear to have PM 2.5s quite well controlled in the UK and Europe, in Asian countries that's much more different. So is it likely that, I guess, those other nations around and areas around the world might adopt similar legislation, or do we need different legislation for those countries? And I think I can open that up to anyone on the panel who might want to have an answer for that.
I mean, I can quickly just follow up on that. So yes, China is looking at China 7, and I think it will be a easy extension, I would say, easy in quotes, in the sense that they do have China 6 and RD set up, so does India. So I think it's taking some of the best elements from the Euro 7 and also from a US Lev 4, which is coming up. So I think that could be done. India, a little more of a challenge, because I think, again, the key there is also to extend these to the PFI vehicles, but it can be done. There are more, I think, considerations from setting up all of the required equipment. Measuring PN down to 10 nanometers is not easy. So again, having all of the robust equipment and measurement technologies in place, all of that is going to take some time and effort. But yes, it can certainly be done. Yep.
And Nick, you've got your hand up.
Yeah, I just wanted to chip in. I think the application of it worldwide presents an interesting tension, which is about the speed of fleet turnover. Because to the extent that Euro 7 will make vehicles slightly more expensive, actually moving from an RDE Euro 6 vehicle to a Euro 7 vehicle makes sense in Europe. But if you've got a fleet which is largely made up of, I don't know, Euro 2, Euro 3 vehicles, the overwhelming benefit is to get those to Euro 5 or Euro 6 as quickly as possible. So it would be so we don't want to slow the turnover of an old, dirty existing fleet by making the brand new ones too expensive. And we see this in Europe, to a large extent anyway. Most of the pollution that we still see in urban areas from vehicles is coming from the older existing fleet. It's not from the latest Euro 6s on the road. So I think Yeah, the stringency and the merits of Euro 7 need to be weighed against what effect that has on fleet turnover. And in these developing countries or other countries generally, keeping that fleet turnover high is probably more important.
Okay, and I think that's an interesting statement, because that feeds into one of the other questions we've got, that clearly Euro 7 applies only to new vehicles. And are there any suggestions from the panel for how we might clean up the existing vehicle fleet? Which I guess you were trying to answer by saying we'd be better replacing Euro 3, 4 vehicles with Euro 6 RDE and beyond.
I think that's right. I mean, it's difficult on a mass scale to retrofit things. I mean, to some degree, changing fuel formulations may be able to help, but retrofitting generally is difficult to get existing car owners to do anything about. Simply creating the right economic conditions that people turn over their old cars for new ones is the most powerful tool, in my opinion.
Okay, thank you.
I'll just add one quick thing. So there are other tools, right, like this new periodic technical inspection that's being introduced in Europe, which makes sure that filters are functioning well in real world conditions. So I think there are some tools that could be, or cleaner city centers, stuff like that, which could be done to make sure that the older vehicles, at least, they're functioning properly.
Okay. Thank you, Emmy. We have two questions which I think can be answered together. One is, what is the timeline for Euro 7 implementation? And then someone who I know is from the industry of implementing Euro 7 says, is it reasonable to expect the OEMs to produce light-duty Euro 7 products in July 2025? Does anyone from the panel want to comment on so we have an answer on the implementation of Euro 7 for light duty is by the middle of 2025. I think the Euro 7 for heavy duty is a couple of years later. Is that correct?
Yeah, that's July 1st, 2027.
Okay, and do any of the panel want to answer on or is it reasonable to expect the OEMs to deliver vehicles in that time frame?
I'll put my neck on the line if you want.
Yes, go for it.
I don't think there's very much chance of Euro 5 being put in force in 2025. There's too much still to do. There's a raging debate in Europe around it at the moment as to whether fundamentally, whether it's going to happen at all. I mean, I think chances are, the likelihood is it will, but it may well affect the implementation date. And as the question implies, that the lead-in time that the industry has got is incredibly short by historical standards. So I'd be very surprised. And don't forget as well, Euro 7 is not fully drafted yet, in that the limit values for the tyre wear emissions is left blank, because there is no test methodology yet defined. And there's a lot of work still to do on that. I mean, that is not going to be in place and all executed by 2025. Obviously, I don't know that. I'm putting my neck on the line, but that would be my prediction.
I mean, I do think it'd be politically quite difficult for there to be much of an extension on that time frame. That doesn't detract from the question about reasonableness. I would imagine a lot of OEMs are really kind of having to divert serious resource to tackle this, because, as Nick was saying, compared to standard industry timelines, this is really, really quick. And in part, I think it's because the publication of the legislation was so delayed. So people haven't had a chance to see it for long before they're implementing it. Because bear in mind that they'll have to get vehicles researched for new solutions and then retool production lines. There's a lot that would need to be done in a very, very short time frame.
We have a little glitch with the communications from Oxford, I think, unless it's my own line.
We can hear you, Sam.
Okay, sorry, I had some glitching then. I don't know if that was Felix or myself, but just carrying that on, someone in the question says, do you see a future for light duty diesel vehicles given the Euro 7 emissions? The after treatment looks very complicated, and with the competition from EVs and highly efficient gasoline hybrids.
I would say yes, very simply, because yeah, it may look complicated, but it works, right? It works. It has been proven that it works for Euro 6. I mean, that chart that I showed, that since RDE, actually diesels have become super clean. They are, they are well, below the limits. And more demonstration studies have been done in Europe, which show that diesels can be clean under a wide range of, there's this Transport for London test cycle, which is like super urban start-stop condition, and on the other end of the spectrum, highway driving. All sorts of conditions and diesels have been shown to work, and especially with new elements like electrically heated catalysts and so on, you can make them even cleaner. So yes, systems get complex, but they can work together.
But I think to sort of carry on in the future, I think we've seen diesel sales falling in Europe for the last 4 or 5 years now. I think that trend will continue, particularly as EVs begin to increase their market penetration. I think light duty diesels will become an increasingly niche market as electric vehicles and petrol hybrids will dominate. That would be my guess anyway.
Okay, thank you. And just to clarify in the chat, there's been a question, what's OEM? OEM is original equipment manufacturer, so the vehicle manufacturers. Someone says in major cities, we got some of the PM emissions are 2 times the World Health Organization limit. So what is the impact on taking the dirtiest vehicles off the road, and how does that compare to the impact of banning modern IC engines and mandating electric vehicles? Felix, you have your hand up.
Yeah, I'll give this one a go. So I think the person asking the question is exactly right, that we know that a majority of emissions are coming from sort of a relatively small number of polluting vehicles. And these may be vehicles that are older or certified to different standard, or frankly, vehicles that have been tampered with in some way. There is a bit of a market for tuning your vehicle in order to get better performance, say, but sort of the emissions really suffer as a result of that. So I think the kind of in-service compliance aspect, so this is kind of having over-the-air kind of updates and measurements of vehicle emissions that are part of Euro 7 will be really important for kind of removing at least some of that behavior. I'm not saying that bad actors won't be able to find a way around it, they normally do, but it'll certainly make it more difficult. So I think to then come back to the point about the WHO guideline values, so this is where a lot of cities in the world, including the one that I live in, the air pollution exceeds the WHO guideline values. Here I think that's where, with time, I could see, for example, low emission zones that currently use Euro 4 or Euro 6 as a guideline might move to Euro 7, and there that would make a contribution, but acknowledging the point I said earlier about transport not being the only source. And I think that would be in part from removing these high emitting vehicles. And as Nick was saying earlier, Euro 6 covers a multitude of sins, if I could put it that way, that some vehicles from Euro 6 are exceptionally clean and others are not. And I think the Euro 7 will really sort of make a low baseline apply to all vehicles.
Thank you, Felix. On a similar vein, we got someone saying that they live in a particular area where the background emissions levels are much higher than they should be. The local authority, I guess, has declared a crisis, but done very little else. Is Euro 7 going to fix or help in those kind of situations? Stefania, you have your hand up.
Yeah, so only as a comment, I think it's nothing new compared. So we already mentioned this aspect in different ways. So I think what Nick said, that the turnover of the older fleet is one of the most important things. So Euro 7 is not automatically contributing to that. It's only saying what's going, what are the emissions of the new vehicles on the streets. And unfortunately, there is a lot of stigma associated with transportation, because the pollution is mainly associated with that, but also associated in the people's mind. But as Felix also mentioned, there are other sources of pollution that like eating and so domestic heating or animal agriculture that are usually forgotten. So I think if we expect from Euro 7 to solve those issues is readily the case. And also the banning of internal combustion engines, a bit connected with the previous question, could be let's say, could have a secondary effect of having a fleet getting older and older, of people not wanting to buy a new electric vehicle. And this could be also a secondary unintended consequence that can contribute negatively actually to the pollution.
Thank you, Stefania. Nick, you had your hand up as well.
Yeah. No, I mean, I think really to echo that on the, I mean, essentially, if the problem is one of high background pollution, that really means that it's not the local traffic around there which is the cause, and those sources are much more likely to be industrial sources, domestic, agricultural sources, and Euro 7 won't touch that. But sort of, I wanted to chip in an allied point, though. I think we do have to change slightly, or importantly, how we think about vehicle emissions, and including brakes and tires in Euro 7 is the key to it, which is we associate vehicle emissions with air quality and obviously and global warming as well. We don't really link it to water quality and soil quality, and that is actually probably the major vector for, say, tire wear emissions, and then how that gets into the water courses and into the food chain. You know, the academic literature is only beginning to emerge in understanding that. And, you know, and there was a very notable recent report from China, which found one of the chemicals that only comes from tires present in the urine of every human they tested in the trial. So that gives us some clue, you know, as to where these other pollutants from vehicles are going. And so, you know, I think, yeah, we need to reassess how we think about it, and don't just go straight to air quality and go for ever lower limits on that, when actually the problems are, or the bigger problems are somewhere else.
Thank you. And Amelia, you have your hand up.
Yeah, I mean, I really like that question. I think we're moving from this era of, you know, just monitoring overall, even though I started off with a slide showing the reducing pollutants. I think we're moving away from now just broadly averaged emissions in a city to really monitoring emissions in the places where we live and work, right? And I think we need to improve upon local monitoring. So that has to improve. And you know, new tools such as remote sensing are being discussed, right? I mean, where you can sample the sort of the tailpipe signature of an exhaust of a vehicle that's going by, and tools like that will help detect high emitters. So things like that have to be done. Also, I'll just mention a couple of, you know, I saw a couple of new studies recently in the last year where the idea was to model traffic hotspots, and based on the vehicle sort of make and aftertreatment control and so on, they could actually predict the NOx and CO2 emission that would happen at various traffic hotspots. One was in London, one was in the US, and it was remarkable how well that model could predict what would happen based on the traffic density in that area. Again, very out of the box thinking, but I think those sort of tools have to be brought. Where I'm going with this is, you know, you could have better traffic management as well, for example, right? And stuff like that, which would then lead to really reducing pollution in a particular neighborhood and things like that. So.
Okay, thank you. I think a little change of tack now with some of the questions we got coming in here, which there's a couple around non-exhaust emissions. And one of those is, do the panel have a view on those non-exhaust emissions? And I guess that's really around, are the particles from brakes and tires comparable to burnt particulate from fuel? And also, are the measurement technologies in place to measure these non-exhaust emissions in real driving conditions? So given the relatively high contribution from these sources, how are we going to measure the non-exhaust emissions? Nick, I'll go with you first as you have your hand up.
Thanks. If I focus on the tyre side, because that's the one where we've done the deepest testing on, just the basic numbers are that a typical vehicle sheds about 70 milligrams per kilometre of rubber from the tyre. And if you contrast that with what comes out of the tailpipe, you're talking about at least 1,000 times more in terms of mass. So just to give an order of magnitude of the problem. The objection which is often raised is that, well, they're all big chunks of rubber and they just collect on the road and go into the drains and we filter them out and that's fine. That's not true. It produces, yes, some larger particles, but also a lot of ultrafine particles, particularly under heavy load, so braking and cornering. But it is a function of the design and the chemical makeup of the tyre. The degree to which that is a problem. Are there measurement methods at the moment? They're emerging. Measuring mass loss is relatively straightforward, and there's a convoy method which is being designed to fulfill Euro 7, but that's essentially weighing your tyres before and after a long drive. How we monitor the ultrafine particles is more of a measurement challenge, not because we don't have the instrumentation, but it's because just isolating the tyre particles from the brakes, road wear, general muck, resuspended is a really tricky challenge. And that's where the effort is at the moment. So we're making progress, but there's still some way to go. Okay,
Felix, I think you have your hand up as well.
Yeah, so sort of building on what Nick has been saying, here in the UK, in terms of PM 2.5, so this is particulates smaller than 2.5 micrometers. Today, the majority of the emissions associated with transport are not from the tailpipe. That's thanks to the success of the Euro 6 and the Euro 5 emissions legislation, which introduced filters in exhaust. The majority are from brakes and tyres and road resuspension. So the panel, my view on this, is this important? Yes, because with filters, we've really solved arguably the problem of tailpipe particulate emissions. And as vehicles get heavier, particularly battery electric vehicles, which can be very heavy, this problem is actually going to get worse, not better. So I think it's really important that Euro 7A applies to all vehicles, including so-called zero emissions vehicles, because they're not actually zero emissions. But also, I think it's coming to the point about the testing. Nick's absolutely right. There are ideas out there, but we're not there yet. And the European Union specifically acknowledged this when they published the legislation. They've instructed the JRC, so this is the European Union's Joint Research Centre in Italy, have basically been given instructions to work on this as quickly as possible. And there's a number of academic papers coming out right now about those tests. But the reason the legislation doesn't include target values is because they don't know how they're going to measure them yet. So this is really important and live academic work.
Okay, thank you. Amelia, did you have something to say on this topic?
Yeah, I just wanted to quickly highlight that I think we've been talking about cars, but for trucks, it becomes an even bigger problem because trucks, the batteries are especially huge and the weight is much higher. And at least 2 conferences in the last year, I heard like a major fleet owner say that he was only semi-joking. He said that the number of tires we are burning on these electric trucks negates any total cost of ownership benefit that we have from operating these battery electric vehicles over their lifetime. And again, what he was joking was, he said, I almost wish like I had tire insurance. That means that many tires that we are burning through. And so a lot of work being done by tire manufacturers and coming up with better compositions and so on. But it's a big concern for heavy duty vehicles.
Okay, thank you. Just realizing that we're getting near to the end of the question and answer session. There's a couple of questions around implementation of Euro 7 regulations and how much do we think it's going to add to the cost of a vehicle. And there seems to be quite a wide interpretation of that depending on who you speak to. Does anyone on the panel have a kind of view on that?
There's a lot of views on that. You're right, and I wouldn't go into the details, but I would just point that there is a very good impact assessment document by the by the regulators, which has been put out, and I would refer to that. I did actually look it up recently, and it mentions for the chosen sort of scenario, it is like a $20 addition per vehicle for gasoline and $80 for diesel, and then more for heavy duty. But that was sort of the range for the chosen scenario. They had 3 different scenarios, and they picked one of the regulatory, right, which is what that comes to. But again, it has a good breakdown of all the components and how all the costs and benefits come up to. So,
okay, and then again, kind of changing tack. There's a couple of questions around I think this is kind of Brexit related. Will the UK adopt Euro 7, or will we just stick with Euro 6 and things like that? I'm fairly clear in what my vision is on the answer to this, but if anyone from the panel wants to chip in, that would be great.
I don't imagine the UK developing its own emissions legislation. I would imagine it would stick with Euro 7, not least because getting different certification for vehicles for the UK market alone would probably result in far fewer vehicles being available in the UK market.
Okay, thank you, Felix. And again, we've got a slight change of tack around kind of local air quality management areas and air quality action plans. And this person is saying that the air quality action plan in their region was dated 2008, and the management area has been in place for 20 years. And I think this kind of comes into a bit about the impact on clean air zones and some of the regulations that councils are using in the UK. Do we think that Euro 7 is going to have an impact on how those clean air zones are implemented, as most of them are currently based on Euro 6 for diesel?
Unless anyone else wants to chip in, I'll give this one a go. I think it's a really good question. I think we need to recognise the pressures that local authorities are under in the UK. Air pollution is rarely top of their lists, although one could argue that it ought to be in some cases, and budgets are constrained. So it doesn't surprise me that the questioners are talking about rather out-of-date action plans, because we need to resource this properly if we want to see the health benefits here. I don't imagine local authorities will be changing their clean air zones anytime soon, not least because we won't see any Euro 7 compliant vehicles till 2025. But give it a few years after then, and I think local authorities, in the same way that they've been doing now, the London ULEZ was implemented 2 or 3 years back. Euro 6 was, I think, 4 years old at that time. So maybe by kind of 2029, 2030, we might be seeing some low emission zones moving towards Euro 7. And as I said earlier, I think that could bring big benefits.
Okay, thank you very much. I think we'll stop going through questions now, because we have kind of 3 minutes officially to the end of the end of this session. But I'd like to thank our panelists for their contributions. I think we've kind of highlighted quite a few of the challenges associated with the Euro 7 implementation. Certainly there's quite a rapid time frame for it to be implemented for light duty. We still have significant challenges around some of the proposed legislation, particularly measuring some of the non-exhaust emissions where the technologies aren't really formulated and the test methods aren't formulated yet. And again, we have this the challenge of, I guess, a social political challenge of, will Euro 7 result in the adoption of more clean cars, or will it kind of lead to more people maintaining their existing IC engine fleet vehicles for a longer period of time? And I guess there's a strong interaction there with electric vehicles. I just wanted to do a quick whip around of the panel individually and see if they had any kind of 1-minute closing statements before we wrap up. So Stefania, did you have anything to add to the discussion we've had so far?
Yeah, no. So only as a summary, I think it's Euro 7 is a good regulation if it ensures clean new cars and vehicles on the streets. But I think the policy should not underestimate the consequences of all the regulations. So we should also pragmatically focus on things that are macroscopically helping us to increase air quality, like exchanging the older vehicles, and also allowing solutions like e-fuels that will allow to tackle also the global warming issue after 2035.
Thank you. And Nick, do you have any comments?
I suppose my overall governing thought would be, it's very easy just to get into a macho contest about who can regulate the most and fastest and most aggressively. I mean, ultimately what we're talking about is enabling social welfare, economic activity, personal transportation in the most effective way, subject to not wrecking the environment. So it should be seen as a constraint. And so the interaction between environmental regulations and how it affects that economic and mobility activity is really important. So if you have something, you don't want to just regulate ever tougher if it has a really bad cost on the things we care about most, which is our welfare in the wider sense. So calibrating the right optimal level of regulation and the impact it has on that economic activity is crucial.
Okay, thank you. And Amelia, your closing comments?
I think all the summary so far is great. I will just add maybe slightly differently that, just sitting here in the US, I would love to see a little more of a give and take and learning from across the oceans. I think there's a lot that the US can learn from Europe in terms of the particle number regulations and all of the advances that Europe has made, and vice versa, right? I mean, the low load cycle in California from that regulates NOx at idling and low load conditions. That could be. So I think we have now reached a point where all vehicles are emitting so low. I wish we have sort of a convergence of these regulations, and it just makes it easier for global OEMs to advance vehicles rapidly. So.
Okay, thank you. And finally, Felix.
So I agree with all of my colleagues here. The number of things I like about Euro 7, but my favorite is the technology neutrality. I've been going on about that for 6 or 7 years, and I'm really pleased to see that. But I think for me, my closing remark would be, let's not forget the bigger picture. We spent a lot of time in the last hour talking about cars and trucks, and actually there's so much more out there that influences air pollution and health. We haven't really talked about modal shifts, about, perhaps reducing the number of cars on our roads. Controversial topic, but an important one. And also tackling all sources of these pollutant emissions, because it really isn't just transport.
Okay, that's great. Thank you, Felix. And I'd like to offer a final thank you to all of our panel members, and particularly Amelia for his presentation at the start, which kicked all of this off. I think it's been a really insightful and good discussion between everyone. So thank you very much.
See you guys.